Guys, there's earthquake here. I'm gonna have to select for a second. There's an earthquake, so give me a second. Sorry about that. There's an earthquake that just happened here, so just caught me off guard. Yeah. Alrighty. Sorry about that. Yeah, there's an earthquake. I'm gonna be monitoring that. Shindo 5, which is the Japanese scale. I guess it says belt magnitude 5.3 here. Not crazy, but yeah. Anyway, how are all y'all doing this morning? Let me turn off this music. Yeah, that kind of threw me off. Anywho, let's get started here. I haven't streamed for a few days. Didn't stream much last week, so I'll try to go for a little longer today so we can get a little deeper into a topic. Usually I cut off about an hour, maybe an hour and a half, 2 hours. Let's see what we can do. Okay. All right, just going back to what we were doing before. If we look through our history real quick, what were we doing last time? Let's just pull up GitHub. It's a little easier it's a little more stream friendly. Okay. Well, first of all, looking at our agenda last time, we started working on our collision system. And effectively, what did that mean? What are commits? So we did our initial. So we added these. Let's add some notes about resizable arrays. Don't worry about that. And then update the planning document. Added resizable arrays examples, notes. Wait, this should be the planning document changes. Yeah. Okay. Nothing big there. Technical design updated. This is stuff about his character data, action properties, and hitboxes. Okay. And then, okay. By the way, how do I sound? Sorry, little shaken by earthquake, but everything's all good. Cool. But yeah, how's everyone doing? Hope you're having a good evening out there wherever you may be, or a good morning, or a good night, I guess. Anyway, yeah. What were we doing? Oh yeah, so we added these basic character properties like health. We implemented this hitbox structure, which just include the top left and the bottom right corners. This is our runtime structure. We had implemented hitbox group, which gives us like a start frame for the hitboxes to come out during move and the duration for those hitboxes. We stored it in the array list, which is a dynamically resizable array as far as I'm aware, or at least you can initialize it to any size. It is not a static array. And we got some action properties, and so far we only have a duration on that. Okay. We made a test. What else did we do? We included in our game simulation, and then we did some finagling here. We made some test data. We just added an initial hitbox to test. And then what else did we do? We called the initialization function for initializing our persistent stored data. What did we do here? Why did we change this? Oh, I guess I got auto format here. Didn't even realize it. I'm gonna change that back. But anyway, yeah, it just auto formatted on me. Oops. Fix that in a bit. Oh yeah, and so we implemented this translate hitbox, which will move our hitbox data to the appropriate offset depending on what we provide, which will end up being the character position. And I'll just generate a new hitbox that we can use. And then we'll check to see if they overlap by seeing whether or not each side of the box is not overlapping the other box. And then if it's not overlapping, then we return true, right? Okay, this is what we did. And then I just had some comments here to explain what's actually happening. The collision system right now is actually doing nothing. It's not actually calling to overlap, because when you iterate all over all boxes, that's still part of what's on our agenda. Oh, is that just checking earthquake stuff? Maybe aftershock. So detected another weak earthquake. Anyway, okay, just keeping that on up for posterity's sake. Okay, so that's what we did as far as that goes. We added some tests to this. We see, man, I need to fix this. I don't like this being automatically formatting here like this. A lot of these changes are caused of automatic formatting that occurred. Okay. And what else? So in our main function, we pass in an allocator that's going to be used for initialization. We changed initial, but this is something we did previously. We should have committed it before. Just changing the space to our game space, the vector space to game vector space, and then why did I add this? Oh yeah, to offset the circle. Okay, and using the game space, and then we translate it using our math world to screen space stuff. Okay, great. So that's what we did. We have a bunch of other things on our agenda now that I wanted to look at. I said I was going to implement a timeline data structure. So this goes hand in hand with all this like persistent data we need to worry about, like data that doesn't change throughout the course of a game. You know, what's included in that? Well, of course, it's hitboxes are included. It's going to be hit properties. Now, it's not necessarily true that hit properties would be static data. You could potentially change hit properties if you wanted a scripting system that let you check a condition within the game world and change hit property. You could do that. We're going to keep things simple. We're going to say that all hit properties are unchangeable data. It prevents us from well, it, you know, we could be a little more flexible with our design if we allowed hit properties to be changed, but that also means hit properties will become mutable data, and it's something we have to keep track with our rollback system, which we haven't got to yet. But we'll just say that's a design constraint for now, and hit properties are something you just have to specify in persistent data, which will end up being in an asset somewhere, maybe something changeable. Well, it will be something changeable by an editor. If you want to have changeable properties instead of changing individual properties, because we don't want to keep track of individual properties as mutable data, we'll have, say, conditional branching within our action system, which will choose between one or more set of attack properties. And our attack properties will be grouped together in a single data structure, something like, hit, damage, block damage, or guard damage, knockback, launch velocity, et cetera, et cetera, et cetera. Either it's a knockdown, does it cause a launch, what kind of reaction it causes, et cetera, ad infinitum. Okay, that's just a little bit of discussion going on here. But just getting back to the persistent data kind of discussion, the whole point of persistent data is, okay, did I write down stuff in the technical design here at all? Let's see, we got character controller, character data, Let's just say persistent data. Okay, let's say persistent data store. Okay, so the persistent data store, constant data, or we can say unmutable data. Unmutable, non-mutable, I don't know what the correct way to say this. Data that, let's say unmutable data. What else properties is it used for? So wow, this is about immutable data. My brain's not working too well. What do I want to say about this? Oh, but let's say allocated or initialized at the start of a match. Not be stored for rollbacks. Will, since it's unmutable, will not be updated by the game simulation, can be modified by the editor to test. Yeah, so our persistent data can be modified by an editor. Our editor probably will be kind of built on top of the engine so that we can change properties and test them while the game is running, such as, we want to adjust our, the hit damage and see the effects of that, or change the type of reaction, et cetera, et cetera, et cetera. Okay. Now, since this persistent data store is something that's used for characters, for actions, actions can have any number of hitboxes. They can have, any number of hit properties, sound effects, et cetera, et cetera, et cetera. Did I write anything about that yet? No. So, why I'm bringing this up is because when we get down to the actual implementation of this, one way you can do it is have a completely statically allocated data structure, right? If you could say just have an action structure that has all those properties, and it's going to have a fixed size. But that means you can't have more hitboxes than what memory you allocate for that fixed size structure. One way you could do it is you can make each structure as big as you possibly need it. Let's say you have 100 slots for hitboxes. Maybe that's enough, but you're not using as little memory as you possibly could, right? And then there are also chances that you need more hitboxes for whatever reason, or other properties. You might need more slots for sound effects. So that approach isn't ideal, and maybe in a world where we're actually allocating those structures in real time, it makes more sense to have fixed size data structures so you can like pull them together in large arrays. But we're not going to go that way. We're going to continue to use this. Well, we're just going to allocate as much memory we need for our actions for each property, such as hitboxes. So for like arrays of things, we'll use that array list that was mentioned in our documents here. Let me pull it up. Zig notes. What's array list? Yeah. So we're going to use the array list for things like hitboxes, for hit properties, anything that needs to be, it needs to be any number of a thing, right? That's what we'll use that here for. And then we'll just use a standard allocator for handling that, the actual reservation of memory for that. So that makes sense. Currently, if we just step through what we have here, and also I apologize, like all this back-end work we have to do is just, unfortunately, this is something you have to get through with game development. You could hard code everything up front, but you're going to have, if you want to start expanding your game, right, you're going to have to go back and do this anyway. So might as well just get this out of the way. And maybe it's interesting to some of y'all. Okay. So yeah, yes. So just going through that again, you said, well, some point at the beginning of our match will allocate memory. Currently, we're just passing in this allocator that's we initialize in our main game loop, so we know it's, well, I don't know if this is set to allocate. So I'm so used to C++ now doing this whole like allocating when it's gone out of scope. Technically, I'm pretty sure this doesn't allocate when it goes out of scope automatically. We have to use the defer command. But technically, you know, main loop was done, the program's done, the memory should be freed. It's not something we technically have to worry about, but we might not be calling this bit of code from main in the future. So it might be a good idea to break this out into, say, like a game init or just a game loop function and call that from main. One reason we want to do that is we might want to run tests. Are we going to run it? Yes, we'll be running input parser will be happening here at some point. We've done a very basic input system that just takes the pulled input from the gamepad and assigns a command to that. But right now it's just for like very simple things like pressing a button, releasing a button. Well, actually right now we don't even check for releasing a button. Yeah, we just assign up, down, left, right, attack for now. And these are just either on or off. And we don't even have any like utility functions to check to see if a button was pressed this frame. That's something we'll have to get to before we even get into full input interpreter. Yeah, we don't even have a command buffer at the moment either. Okay. Alrighty. So that's where we're at with that. Where was my train of thought going? Yeah, just going back here. So I do want to break out the allocation of our persistent data store into something else, and then I'm probably going to break out the game loop from main, put it into another a file so that we can handle the stuff like allocating. And the reason I want to do that is I might be wanting to write these like simple simulations of aspects of our engine, and it just makes sense for me to break out test files in that way, right? I want to maybe allocate some data store here, use the gameplay systems in another file, and just have this stuff available without having to go through the main game loop like this. This was something I was really thinking about before. I wanted the ability to spin off tests really easily as we're building this, because it's kind of a problem when you're building your whole game up from these basic pieces and you can't even test the basic pieces, right? Which we've done before as unit tests, but unit tests are one thing. that lets you to see if a function is working as expected. Basically, you given the certain inputs, it has the correct outputs. Has your expected outputs. But when you start integrating all these pieces together and things are running in a loop, right? That's not really unit tests anymore. You need to like test for higher level behavior. And in the ideal world, you have everything done, and then all your behavior is done. But you can start testing behavior before you get to that point, right? If you expect like your collision system to work in a certain way, you don't necessarily need the full game to be running for that. You just need the collision system and maybe some hitboxes on screen that needs to test. And if it produces the results you expect, that's good enough for testing that system, right? And it works in isolation. And then you expect it to work when you integrate it for the rest of the engine as well. Okay, that was kind of an aside. But anyway, yeah, so you've seen here, I'm not actually freeing memory that's used by the arena allocator. And let's see. Let's just say at the bottom here. This allocator takes an existing allocator reps and provides an interface where you can allocate without freeing and then freeing it all together. What is that? Where you can allocate it without freeing and then free it all together. So this is kind of what we want, right? We have a persistent data store. We don't need to free everything individually, because once we free the memory, when our match is over, we don't care. We can just like free all the memory, because we're not going to use that persistent data store again. Now you might have rematch. In that case, we will not free memory, but there's never a case where we're going to free part of the memory from this allocator, because we're not going to be using it to allocate memory in real time. And that means we don't need any of its consumed memory to be reused for other purposes during a match. That's just a design of how things work in this fighting game, and generally most fighting games. Okay, can I go to the definition of this? Anything else useful here? This allocator takes an existing allocator, wraps it, and provides an interface. Okay, where you can allocate free without freeing. Okay, got it. Inner state of the admin. Okay. That's interesting. Okay, I do want to look at this arena allocator though. So they do defer this arena dinit here. So going back to our game. Oh yeah, just defer command. I know a little bit about it. So this is what they say here. Which allocator to use? What allocator to use depends on a number of factors. Here's the flowchart to help you decide. Are you making a library? In this case, it's best to accept an allocator as a perimeter and allow your library users to decide what allocator to use. So we're not making an allocator or a library, but we are making a game, so we might want to have flexibility in changing our allocator. We'll go back to that at some point. Are you using libc? We're not going to be using libc, so we're going to know that for now. Is the maximum number of bytes you will need bounded by number known at comp time? That could technically be true, and probably we want that to be true. We want to assign budgets to our game, but for now we'll ignore that. Just put it on the side, right? They said you should use the fixed buffer allocator or standard thread safe. Okay. Let me just write that down into our notes real quick. Let's see. Okay, I do notice this though. It's the maximum number of bytes that you'll need bounded by number known at comp time. So I don't know if we'll actually ever know it at compile time, but it's more like, Well, it says maximum number, so it's not actually going to allocate that memory at comp time, or I'm sorry, it's not going to assign that memory to be allocated at comp time. I don't know. We'll get back to this. It's your programming command line application which runs from start to end without any fundamental cyclic pattern, such as a video game main loop. Well, that's what we are. Or a web server request handler, such that it would make sense to free everything at once. And then, in the case, it's recommended to do the following pattern. So, despite the fact that we are a video game, with a loop, the data we're talking about here is persistent data. We're not talking about allocating data on the fly. So it makes sense for us to do something like this, right? So that's why we're using the arena allocator. It's interesting that, going back to this, they choose to use this page allocator thing. Okay. Wait, when using this kind of allocator, there's no need to free anything manually. Everything gets freed at the once with the call to arena at the end. Oh, yeah. Okay, that makes sense. So that's what we're doing here. We're free everything at once. Free everything at once. And what the defer commands does is it doesn't call this immediately. It waits to we got a scope, right? Anybody who's new to here, feel free to ask questions at any point. We're not in a race here. We're just taking our time figuring this stuff out. Okay, this is not a tutorial. We are just documenting the process of building a game here. Okay. I'm just studying allocators here anyway. Finally, if none of this applies to you, you need a general purpose allocator. Zig's general purpose allocator is available as a function that takes a comp time struct of configurable options and returns a type. Generally, you set that up one general purpose in your main function, then pass it or sub-allocators around to various parts of your application. We might use this for other parts of our engine for mutable data. I don't understand it enough, but yeah. Okay, I don't want to look into implementing our own allocator right now. That is just getting way too much in the weeds. How important would it be to choose an allocator for memory that isn't allocated or freed during a match? I'm trying to think of any gotchas that would happen if you choose bad allocator. I mean, it mostly depends on how you're handling the data, right? If you're looping through a bunch of hitboxes, you want all that memory to be adjacent. You don't want it to be like partitioned into chunks all over the place. Now, I would hope an allocator would not just do that by default, but if you page memory in small enough bits, right, where you have a chunk of bytes, and then you have another chunk of bytes, and it's one chunk is pointing to the next, to the next, to the next. You can end up having these partitions, and you don't want those partitions to be so many that you get performance problems. You want your pages to be sufficiently big. In the ideal world, you would want everything to be allocated in one chunk of memory, right? That's kind of like my ideal allocator for persistent data. Just it gives me the option to be able to, as quickly as possible, iterate over chunks of bytes at a time, such as a sequence of hitboxes. I'm no expert, but this is my kind of intuitive understanding of what would be best as a allocator for something that's not actually reserving memory or freeing it in real time. Yes, exactly, Ozymandian. It would increase the chance of such a chunk of hitboxes fitting into one cache line, or at least getting down to L2 cache altogether. Yeah. At least on console, we have known memory limits, so we know we could really pick, even at compile time, how much memory we're going to use, right? And we know we're going to get that memory when allocating it on console. PC is a whole nother story, right? We don't know anything about what our game's running on, other than maybe architecture. At least it's for this. I mean, technically, people can compile this whatever architecture they want. It's supported by the Zig compiler, but yeah. And actually, in the future, they're having a C backend for Zig. So technically, I guess you could compile it to like anything, as long as you compile the Zig standard library. And you can compile these C libraries. I don't intend to link against anything that's not a C library, but yeah, just hypotheticals. Yeah. Okay. Yeah. Where was my train of thought here? Okay. All right. So we just put this to initialize, deinitialize our memory here, right? And let's see. Okay, and then this obviously does that. Anyway, so what I want to do here is implement a game loop function, move some stuff out of our main loop here, just for more flexibility, basically. I usually frown at abstraction, having too many layers, but in this case, I think it's worth doing. So we got our main here. Let's add a new source file. Let's just call it game.zig, right? And then basically what we're going to do is copy the main game loop here. Not even the main game loop. We're going to copy like everything, right? For pretty much main is just going to set up. Yeah, it's just going to set up pretty much everything from here to here. Then we need to include, let's just include everything here at the top. Then we include main. And then we need a function for all this. I'm just going to call it game loop for now, because that's easy to understand. And returns void. And we're actually not going to need that here. Okay. And then main, we'll call it everything from close window to allocation here. And then we're going to call game.gameLoop. And we're going to have to import the game. We don't need any more of this anymore. Oops. Okay. And then hopefully that'll work. So our main function is clean. We don't have to really look at this file anymore, other than maybe setting up some Windows stuff. Okay. Did get an error though. Const game import. Oh. Able to find game. What did I mess up? Maybe that's the problem. I don't know if that's public. At some point, hopefully get intuition about what's wrong when I'm working on Zig files. Is it because it's const? Can I have it const? Unable to find game. Well, the thing is, I have const for all the other things that are definitely mutable inside the library. So, and able to find game. What am I missing? It's the same folder. Same folder. What is the problem? Why can it not find game? Oh, duh. It's not a. I actually have to do the zig file thing. Okay, got it. Because it's not a module that I set up. Okay. Defer arena. Arena 12. Oh, duh. Okay, got it. Because that was example code that I copied. Unused function for the collision system. Okay, I wish I could just quickly go to that. Okay, game system 109. Unused function parameter. Game state. Well, this will let us. Okay. This just lets us like say the parameter is unused and compile. Okay. Cool. So it works. There we go. This is just our hitbox we're drawing here. So we've now separated this from this. Fantastic. What else are we gonna do here? Cool. Well, we're making good time here. It's not even 40 minutes into the stream yet. So what have we done? So we have our persistent data that's initialized by our game loop. Or at least, sorry, our allocators are initialized by our game loop, and we pass that into the game simulation, which keeps track of it in its own allocator parameter. Ultimately, the game simulation, the game simulation right now is tracking persistent data, and let's just keep it that way for now. Yeah. I feel like this is a kind of an additional unneeded step. So what I'm going to do is, well, yeah, anyway. I think Zig has a kind of, there's often a pattern of like using kind of a factory when you're constructing a new object like this. But I'll leave it like this for now because it works and it's fairly understandable. Anyway, yeah, so we initialize our game data with this function. And then we set up our entity by registering these basic states, right? By the way, I noticed when we were testing that I can walk right but not walk back. And that's because we don't have a backup state yet. Got it. Makes sense. Okay. Cool. So what do we want to do next? Well, we want to add more hitboxes, right? So we need to add more hitboxes. We need to store them in the hitbox group, right? There's a lot of different things we need to do here. So we need to, for a test, we need to store hitboxes. We need to run them through the collision system. We need to generate hit events. Of course, we need to have another character at some point. We need an attack. There's all kinds of things we need to do. It's a huge list. So let's just start writing those things down. I think we've written this. Okay. And we still haven't gotten to this timeline data structuring, and this is going to be important too. Let's put down our agenda. So free persistent memory store at the end of a game, which we've done. This is mark that off. And we've also added implement we've done that. Let's mark that off. So there's all these other things we need to do. Like let's mention again, we need to create a bunch of hitbox data for our character. This is what else we need to do. We need to run the hitbox data through collision system. We need to generate hit events when hitboxes overlap. We need to create a second character to test hit interactions. No, to test hit interactions. What else would I say we need to do? Oh, we need to create an attack state. Create attack action. We need to create a reaction action. So we have all this stuff we need to do and prioritize. And the thing is, I need to, it's kind of, we could do these things in various orders, right? But at the end of the day, unless we have all these pieces, we're not really seeing the thing happening on screen yet. I'm just trying to think what we want to get to today. I mean, so things kind of need to happen. This not so much yet. So we need test data to run hitbox data through a collision system and to generate hit events, right? So create test hitbox data to test collision system. We need create test to we need to create a test to test hitbox collisions. We need test hitbox collision hit event generation. Okay, so we need a hit event structure. Oh man, Ozymandian, thanks for dropping by. I know it's late for a lot of people out there. So really appreciate you coming by. See you very soon. Have a good one. Okay, so you need test hitbox collision event generation. So actually we need collision event structure. So this has to come first. So we need to break down into our data structure, right? And then the actual processing of that, the data. We've already made the hitbox data itself. Well, we've created the structure. We haven't created any hitbox data for testing. So then we'll have to eventually make a hitbox data for testing. And then we'll have to test the actual hitbox generation. Yeah. Okay, we don't need any specifics for our hit collision events yet. We'll get to there. We haven't mentioned this, but we don't need that part to actually test any of this. So we just need a structure. So for now, we'll just make an empty structure. I hope that sounds good. And on top of it all, I want to move the hit collision system to its own file. Okay. So let's make a new file, collision system.zig. Okay, and then what we're going to do is first make sure that everything runs in the collision system that's running in this file, which is pretty much nothing at the moment. Move that to its own file. We're going to get rid of this whole comment thing because we know pretty much what we're going to do here. We can always look at the diff anyway. We need to import game state equals. Well, we don't. Hold on. I don't know where. We'll get to here real quick, but what we need to do is, what are we importing for the collision system? We need at least the character data. Okay. And we need the collision code. We need to move that out as well, right? So, yeah, all this collision code we're going to move out of here into our collision system. And for now, this stuff's going to be local to the collision system, so we want to expose it. And then what else do we want to do? Let me close the game.zig for now because we're not going to be looking at that. I move documentation over here. Main as well, we're not looking at that. So do we leave our test in here? It's fine. Okay. And at some point, just a note, I'm going to move these systems to their own files as well, because they're going to have their own data there. Well, the systems will all work with components, but we'll get to there. They'll have their own utility functions and things like that, probably. Okay. So you saw before in our documentation here. Let me pull it up. Yeah, so we made the pseudo code here, right? We're basically we're going to loop through all the hitboxes on the attacker, and then on the vulnerable character. So we have to do something that in our test, right? Woo. And actually, for loops in Zig, what do they look like? Did I have been using a for loop here? Oh no, I'm using a for loop. There's not like the C style for loop. You have to use while, right? And that got formatted in a way I don't like. Anyway, fixing that. I know Zig's way of doing it is like that, but yeah, while I'm looking at it, I'm formatting that. Okay. Yeah, so you have to do something like this for looping over all the entities, right? So one way you could do it is we could just loop over all the entities like this. We're not using the state machine. We can do like attack entity index. So we could loop through all the attack entities, and then we could loop through basically an into, type situation. This is our first way of doing this. It might maybe the ideal way. One way I'm thinking of handling this, I've done before, is you accumulate all the hitboxes in the space that you need it in, because we're gonna have to like offset them for each entity anyway, and then you run the collision system on those allocated hitboxes. Now, that means we're gonna have to like use pulls for that current active hitboxes. That will give us memory limits, and we won't actually allocate memory on the fly. We'll have to do it at the start of the game. So it means this system will have. It means it would have, in theory, state that could be persistent between frames and cause deallocation issues. So it's always something, sorry, would cause desynchronization issues online. That's something you always have to keep in mind. So you would have to, you could either clear the memory at the beginning, or basically, as long as you write it correctly and only iterate over the hitboxes you are using that frame, it shouldn't matter. But anyway, that's a digression there. Won't do that for now. We'll just loop over all entities. It's not the most efficient thing to do, but I'm going to come back to this and maybe handle it in that way. Okay, so we're going to go through all entities. And assume they're the attacker, right? And then we will create a vulnerable at the index, or defending. Let's say defending entity index. So we got attacking, defending. Okay. So you can think it, or you can think of it as offense, defense as the game. Yeah, Zig's a cool language. It's very close to C in a lot of ways. It's meant to be a C replacement. It's like C with nice things. You know, all those nice things you wish you had in C. That's what Zig has. It has built-in tests, which is very handy. Okay, so yeah, we're going to loop through all the entities, assuming they are the defender. And in C, I'll do something like this. If I want to make sure that we're not checking the entity against itself, so it would we have to do something like this. If entity index equals, sorry, I didn't want to do that. So if defending entity index equals the attacking index, I would do something like, in C, I'll do continue to scoop over the loop. But I don't think does Zig have a continue command? Let's check that out. It does have. You just continue to jump back to the beginning of the loop. Sweet. So it does have continue. So basically we say, do not allow attacking, do not check hitbox collisions against the same, do not check an entity's hitboxes against itself. Okay. So that skips over that, and then we can do some cool other stuff, and this labeled while stuff looks useful. Okay, but anyway, we're going to stick with the while loop, because Zig doesn't have the C-style for loops, where it automatically iterates, increments a variable or an integer. Okay, so we're going to go through all the attack entities and then all the defender entities, and then we need to check each of their hitboxes against themselves. So we're gonna have a lot of while loops here, unfortunately. Yeah. And we're gonna break it down to make it simpler here in a bit, but yeah. Does it automatically format the while here? Or am I doing that by out of habit for some reason? I don't know. Okay. Now we're gonna have to do something like this, right? We have to have a attack entity hitbox index. This is starting out of control with these names, but bear with me. Now this is gonna be less than whatever the hitbox count, right? we'll just comment this a little bit. And then we'll have to do something like this, like we did before. So attack entity, oops, the hitbox index equals 1. And then inside of here, we'll have to do this. This is starting to get little. A lot of code smell going on here, right? But this is like the conceptual thing that's happening. Yeah. So inside of here, we'll have to have a defending entity index, hitbox index, right? And then we'll have to iterate that as well. And you can start to see code like this could easily have errors in it, right? So all this complexity to iterate over all the hitboxes for all entities, right? But we'll start with the conceptual stage of this, how things should work, and then we can start thinking of ways of making it cleaner and less bug prone. One way you can handle is thinking all ahead of time and then doing it, but yeah. Getting up an hour mark here. I might take a 5-minute break. I do want to continue streaming, but yeah. So we got to this point, and it's a point if we're test, all we're doing is testing and seeing whether or not we are iterating over everything, right? We're not actually generating any events. We're not actually doing the collision. At some point, we need to get the hitboxes from the characters. So now it's on us to go, okay, where are the hitboxes stored? Right? Well, if we go back to our game, actually we don't need to be in the game, we need to be game simulation. We stored hitboxes in hitbox group. We just have this like raw hitbox group thing. This is not going to be good for us, right? We need to think about the data in terms of per entity, right? One way we do it is just have so where was our character data? We stored that somewhere, right? Go back to our character data. So we have character data properties. We just have health right now, max health. But let's bring this down here to our below our hitbox group. We could have a we could have a hitbox group per character, but that's not good enough, right? We need hitbox group per action, right? So before we get really deep into this, well, this is for now. Let's just put placeholder kind of stuff here. So we need to bring the action properties above here. So what we need is, conceptually, we need hitbox groups to store hitboxes, action properties to store hitbox groups, because hitbox group represents basically a set of hitboxes per range of frames in the action. And then we need to store a set of actions properties for each action within the character, right? So that we know which properties to use per action, right? Like attack or punch or jump or walk, whatever. One way you could store it is just have a flat array, right? We could say actions, and that would be like an array of action properties, right? Now, we mentioned before, we could have potentially any number of actions. So we wouldn't use something like a plain array here. We'd have to use something like an array list. So in this case, it would have to be action properties. Like this. Oh, we need a comma here. And the same thing would be the case for for hitbox groups. We would need hitbox groups, and that would be again, standard array list. Okay. Oops, not action properties, but hitbox groups. Hitbox group. Okay. So that does work, right? At least for now, that's probably good enough. So when we want to get hitboxes, we have to get the character properties, get the current action that's running, which in this case would have to be indexed with an integer, right? Not with a name or anything like that if we're storing it like this. If we want to use a name to find the action, we would have to store a map. Or we could store all this in a hash map as well, but that's a less efficient data structure. Well, you still can iterate over it, but the thing is, we're not actually going to need to iterate over actions, right? We're never going to iterate over a set of actions. If we're able to do compile time hashing, we could have this as a hash map and have constant time lookup, right? Because we would know the offset of the action, but we actually don't know at compile time the number of actions they're going to be here. So there could be problems with that. And we might have an editor where we change the name of actions, things like that. So for now, let's just store things as indices. And we'll have to have some way to cross-reference an action with the current state that's running, on the character state machine. How are we storing? Let's just go back to how we're storing actions in our persistent data, right? Actions are stored, so we register them. We register the action, all the code that's used to run it, and then we give all the callbacks for the action. And how do we actually choose the action, right? Oops. Hold on. Well, within the state machine itself, we go back to our common actions, right? We can choose the next state. And it's stored by referencing it directly through the combat ID. Well, not directly. So currently we have this combat ID. Give me a second here. That's not earthquake, right? Yeah. And this is just going to be, it's going to let us use an offset, right? To pull in the current state. Where is it at? That's not going to work there. So yeah, this chooses the next state this way. So we'll have to do something like enum to int to get the index of the state. Okay, that's fine. We'll store it like that for now. Seems like it'll work. But at some point we need to allocate or create the action data within our, at least within our test code. And in the future, we'll have to provide, we're going to want to provide editable, or at least something that we can do offline, aka when the game's not running, a way to create that data either a tool or through text files or whatnot, so it's not hard-coded within our Zig code. Right now we could hard-code it, but give me a few minutes here and I'm going to go get some water. Take a short break. I'll be hold on real quick. Do something here. I'll be right back. All right, I'm back. Let's get this started. So we left off. What was I doing? We were looping through all the hitboxes for all characters. And the truth is, like, I don't really want to pull the hitbox data directly from a persistent store like this. Our collision system isn't so much about reading that stuff, right? It's all about just checking if collisions occurred. So I want to reduce the complexity as much as possible from this bit of code. So one simple thing we could do is add a utility function for pulling in the hitboxes and then doing all the offsets for those. Because really, again, the collision system doesn't need to really know that much about the persistent store or about the other parts of the entity state, just enough so that it can actually offset the hitboxes. Another way we can handle this is do a pre-stage for the collision system that offsets all the hitboxes. But again, I think I mentioned before, it requires more memory use. It may not be large, but it's just something to be aware of. But I think either way, can't really get away from. So we kind of have two choices here, right? We could either at the very end, well, at the leaf nodes of our loop, right? We could do the offsets for the hitboxes, which means we don't actually allocate any memory, or just enough for the individual hitboxes we're testing. But that means we have to keep offsetting each time for each new hitbox. And even if we check the same hitbox multiple times through multiple entities, we'll have to do the same operation over and over and over again. Now, it's just going to be a simple add 4 times for the offset, so it's not that big of a deal. As far as like computational performance goes, it's just a few cycles at the end of the day. And it may be better than pulling in a bunch of hitboxes. Well, the truth is, though, depending on how we do this, we're going to have to pull in the hitboxes anyway from main memory. It doesn't matter if they're pulling for persistent store or not. So something you have to keep in mind. So I'm leaning towards doing a pre-processing step on the collision system so that we can like go ahead through all the entities, update all their hitboxes that are processed, and then actually process the hitboxes, the offset hitboxes, through the collision system. And the only reference to the character would be the entity ID, and we can use that in the collision system. Sorry, in the event for generating the event. So instead of doing this whole wacky thing and checking collisions here, we can pre-process hitboxes within this loop, right? But actually, I don't want to do for this. I want to just go through all the attack boxes and then the defending boxes. So we're gonna have the pre-processing step. Okay. So here we're just going to generate all the hitboxes. Generate hitboxes used to actually check collision. So we're going to go through all the entities. So we're going to go back to using entity index. And for now, let's just say entity to make things simpler. And get rid of this. And then we're just going to pull in the current defending hitboxes, right? So, well, let's say attack hitboxes for now. So get all offset. Well, get active attack hitboxes and offset. So we're going to have some utility function like get active attack hitboxes, and just pass in the entity index, something like that, right? And we do the offset, right? We have to do like you know, translate hitbox. So we do something like, yeah, we have to do something like maybe loop through it or whatever. So yeah, conceptually, like loop through all active boxes and offset. Yeah, so that's what we do. So actually, how do we implement this? So first, well, let's skip the actually getting part first, and then let's see how we handle it translating each hitbox. So we have the offset. So we have to get the entity offset first, right? So let's get const. So it's a constant here, entity offset. Offset equals, well, we need to get it from the character's mutable state technically, but we don't have access to offset directly, or actually the game state. We do need to import game state, right? So oops, sorry, const game state equals import game. Is it game state.zig or is it game simulation? Do we have a game? No, it's a game simulation. Okay, game simulation.zig. So we need game simulation. Okay, so we should have access to game state with this, right? So game state dot, no, hold on. We should have access to, why don't we have access to, yeah, we need a physics component, right? We should have a physics component, right? But why can't we access it directly? What's going on here? Is it because it's not public? No, that's not right, because we could just do that. Oh, maybe because it's not exported, that's why? No, we did that in the game before though, right? So we're able to import game simulation and then use it directly like this, right? So what's the problem? Maybe it's just that the, I don't know. Maybe it's just that the autocomplete is not working here. Let's assume that for now. Okay. And actually I want to go through here and import the collision system. Oops. Okay. Close this for now. Okay. So we should be able to get the entity offset with, is it gonna figure it out? Nope, it's not gonna do it. Alrighty. Alright. Do I have to import component.zig directly? I don't know. Hopefully I don't have to include it, but yeah, it should just be position. Right? That should just work. And then we're gonna have a call to translate hitbox at some point. We're gonna type in hitbox, and then we're gonna have to type in this entity offset, of course. Okay. And we need to implement this get active hitboxes function, the utility function. It's gonna be something like get active attack hitboxes. Let's just say for now we need to type pass in the game state so we have access to everything in the game state. You know, and then I forgot how to make this const. Is it like, I don't know if it's const like that or it's a pointer to const. I think that's makes more sense, right? And then we need to do, what is it? Entity. Yeah, the entity. Okay. Oops, and that needs to be you unsigned. Or how do we storing? Yeah, I think that was what was it? Usize. Okay. And then return, needs to return a set of so we could return a copy. One thing we could do is return a copy of all the hitboxes that are active. This is getting tricky here. So this is like where code starts conflicting with design, right? An optimization would just be to return a pointer to the current active hitbox group, which means we can only have one active hitbox group per set of frames, right? Right now our code technically does allow, well, at least our data structure does allow multiple hitbox groups per frame. But for simplicity's sake, I think I'm just going to return the hitbox group, a pointer to it. So would be a pointer to hitbox. Actually, it needs to be an optional, right? It needs to be an optional pointer to hitbox character data.hitbox group. But I hope you guys can see how like complexity builds up on top of complexity. So trying to get things simple is really difficult. But yeah, so we could potentially return null, or depending on whether or not we find active hitboxes, right? So we still don't have access to game state directly here. Okay, we don't. I don't know why. I think maybe I messed up something, but there should be persistent game data here, right? Yeah, game data. So is game data? So the game data we need per entity character data, right? So we have character data dot character properties. So we need character properties. Yeah, so character properties needs to be equal to, or needs to be the type of this, but we need to have an array. And you know what, I'm just gonna make it static for now. So it's gonna be 10 of these. We'll get back to this whole thing and handle this in the future, but yeah, because we're still building up a lot of complexity right now. We're an hour 30 minutes in. Well, granted, a chunk of it was a break. Okay, we're gonna have to allocate this at some point, right? This is kind of test code. I want to get rid of this soon enough. Yeah. Okay, so just so that we can get to this point where it compiles, we'd have to get like game data. Again, it's just not, it's just kind of making it a little slower to work with. Oh, it's a lowercase game data. So that's another thing, like, this is even optional, right? So it's like, shite. So if we have to do something like this, game data, to work with it, to check for the optional stuff. Otherwise, we're going to return null here. And then if the game data is active, we need to get character properties of the entity passed in. Granted, entity index could be out of range, but keeping things simple for now. We need to get the on the character data. We need to get the hitbox group or the actions, and then we get the current. Say, we gotta get the actions, and we gotta get the hitbox group. So before we do all that, right? Before we do all that, before we handle actually getting all this data through these stages, I just want to test the code. Like, if we're just going back to our agenda, what are we doing here? Yeah. So we need to run hitbox data through the collision system. This is like, we don't actually have access to the data directly through the persistent store for the character yet, but we can test running things through the system, right? So as test code, we're not gonna do anything with this yet. We're gonna return a single hitbox group, and for now, let's leave it null. And right here we get active hitboxes. This whole thing where we're like looping through, getting active hitboxes and translating them. That's important, right? But for testing purposes, we don't need this to actually generate hit events. So for now, I'm just going to copy all this, or comment this all out. So we're gonna have like, I'm gonna call it scratch memory. Well, it's gonna be something that's generated from the pre-process that we're doing here, the pre-processing step. So conceptually, we're gonna have constant data bit because we're not modifying on the fly. We're gonna have constant like attack boxes per entity, of course, but so it's gonna be a list of up to 10 right now because it's assuming 10 entities. I don't want to allocate memory on the fly, so we're going to change how we handle the list in a bit during like a setup phase. But for testing purposes, we're just doing this. And it just needs to be the current active hitbox group. Okay. So was it character data.hitbox group? So we need a set of hitbox groups for attack boxes, and then a set of hitbox groups for defending boxes or vulnerable boxes. Okay. Vulnerable, defending. What language do we want to use? Let's say vulnerable boxes. Okay. Attack hitboxes, vulnerable attack. That's the state with boxes. We know what that is. Now the problem is this hitbox group has an optional in it. Right, we need to allocate the memory. For testing purposes, we could do that right here, but let me just see if this compiles real quick. Since we commented that stuff out, it should compile, unless I have errors somewhere else. Yep, where's the errors? Tell me go. Expected comma at 25. What did I do? Game simulation. Oh. Oops. What did I? Oh, duh. That's why. Error expected comma again. Use of undeclared identifier math. Oh, because I did not include the math library. Okay. That's under utils, right? We can just come up here and grab it. Our character data has a problem. Okay, on 24. Again, I'm putting semicolon. I'm so used to semicolons from C. These bad habits are just stuck with me. Okay, identify game state. Eventually, I'm going to have good habits about Zig, hopefully. Good intuition. So game state is not a known thing. It needs to come from the game simulation. That is correct. Then it's going to say unused function parameter. That's fine. We're going to say equals game state, and then entity, and that's equals entity. So this indicates it's unused. And unused for now. Okay. Error used undeclared. I didn't remember game state. Oh, game state. Game state. That's not right. Use of undeclared identifier. Oh, identifier is a problem now. 41. That also needs to be game simulation. Game state. Variables must be initialized. That makes sense. So these variables uninitialized, and we could do that thing again where you do like this. I think I've done something like that before. What this means makes 10 copies of those, as far as I understand it. Okay, since they're unused, we get an error. Does this let me test? Does that work for local variables too? To indicate like they're unused. Error, missing field character property. So it requires, wait, hold on. That's a different place. Oh, so the character properties have to be assigned by default. Okay, so let's comment that out for now. Zig is careful. It lets you know when things are not being handled properly. It's one nice thing. It's not as nice for, well, it's not as convenient as for prototyping because you kind of want to get things just to run, but it's going to prevent bugs in the long run. So I do like having that, those kind of errors popping up on me. At least it requires me to be explicit. Like, I'm not using these variables yet. I'm just going to say that. Okay. So we have these initialized hitbox groups. Basically nothing in them at the moment. So we're going to have to create some test data for this. But at least now we can kind of like write our collision code. So we can get back to doing this, like doing this again, right? So we can go attack entity, and then we can do our, attack entity plus equals 1. And then we can do while entity, whoops, not entity, but attack entity. And we can get var vulnerable entity, defending entity, I don't know, defend entity equals, it's going to be uSize equal to 0, like that above, and then we'll do this kind of thing, but with the defend entity, and then defend entity 1. Okay, so we're looping through both of these entities sets at the moment. We probably could just iterate over the attack box sets and then the vulnerable box sets. That's probably a better way to go than using the entity directly, but we probably need the entity index anyway at some point. So let's just stick with that. Okay, so what we'll do here is we'll get our attack box. Attack box is going to be equal to the attack box's attack entity, right? So we only need to pull that in once per loop, this outer loop. And then inside, we need const defend box. It's going to equal to the vulnerable boxes. Defend, no, it's just called vulnerable box. Vulnerable box. Oops, and it's going to be into the defend entity. Okay. And then we can just do, we're gonna do a call to this, right? Do hitboxes overlap. Let's do that for now. Oops. And we just need the two boxes, right? Box A, box B. Okay. If attack box and then vulnerable box. Okay. We're gonna do some code here. And this is where we're actually going to generate hit event. Generate hit event. And also we need to continue if this is the same entity each. So, right, like, sorry, I'll move this here to make it more clear where things go. And if attack, oops. If attack entity equals defend entity, then we'll just continue. Okay. Okay, so that's what basic algorithm we have here, just looping through all the entities. When it's not the same entity, do hitbox overlap and generate an event, right? And we're going to go over each of these, see if this works. So we're almost here. So we do need a hit event. So let's just need hit event is going to be equal to struct with nothing in it other than, for now we might, we'll say the const, can it be a const? I don't know. Any of this, just say attacker is a uSize and defender equals a uSize as well. Is that a problem? What's going on? Oh, it can't be semicolon. Okay. Yeah, do we need, I always forget, do we need, we do need, okay. We need, let's make it pub. And then we need a list of hit events. And the hit events will be processed later, so at some point we need to store a component for these hit events, or we can store them on the character itself. It's not that important. What is, it's going to matter at some point, but it depends how we're going to process the hit events. But I hope you see, like, in game development, testing is very hard, right? Because it's incredibly important how you handle your data. And it may or may not be in the format that's easily testable. And it's hard to test parts of the engine, parts of your gameplay code in isolation. I hope you can see why that is. Or at least get some intuition about it. Because you see, we have to isolate all these pieces for them to be testable, right? And this is a big part of why people don't write tests for gameplay code. It's incredibly hard and time consuming to decouple all this stuff. A lot of programming books, a lot of educators will say, hey, okay, well, it makes sense. You should decouple all this stuff, abstract things away. And on the surface, yeah, that does make each piece more understandable, more testable. But on the other hand, it could be less performant. It can actually be more confusing because when you look at code in isolation from where the data is actually working on, or on the other systems it's working with, you can kind of lose track of the whole picture. It also means people might try to use your code in isolation in ways it was never intended to be used, and now you become a maintainer or of all the places that code is used in, right? As soon as you pull code out and extract code into a separate function, and you expose that function publicly, it might be used by someone else on your team. And at that point, you can't change that code. But instead, if it's part of another function, a block in another function, you can't pull that code out, right? Unless you copy paste it. So they're forced to, yeah. Oh yeah, I think ECS is great for testing, right? Because it forces code to kind of work on its own little bit of data, and one iteration you could check the expected outcome, right? You can you run one loop, run the system, see what comes out of it. That's one reason for using ECS, right? It's not really talked about that much, but I think it is a huge benefit of it. But yeah, so speaking of that, I mean, let's just say we're going to have a hit event component. So and it's kind of interesting. So this is again, we get sidetracked here. We get, off on a tangent, but it's important, I think, because we need to really think about how our game is going to work and be honest about it. If we made something like a hit event component that stores our hit event to be used at a later stage in the game, such as the reaction system to decide which reaction to go to, that would work, right? We can have that data stored for a later stage, but if we follow this strategy of having component systems work on, again, I mentioned this before, the data could sit around for the next frame, and we have to be careful to clean it up. I'm just wondering if there's another way to go about this for one-off sets of events like this, I don't want to be loosey-goosey with how we use terminology here, Yeah, we could call it a component and just make an array with a set of hit events for every single entity in the game. The truth is we might have multiple hit events, right? You can get hit by multiple, or it's potentially a situation, potentially true, that we have like projectiles hitting a character while the other the other player's hitting a character. And do we want the collision system to resolve that, right? We could say, okay, on one hand, we could say the collision system prioritizes one over the other, then we only have to generate one hit event, right? Or do we want another stage to be the filter for that? Do you want the reaction system to be the filter for that? These are all like design questions, and they all have consequences to the behavior of your game, right? No one way is ultimately better than the other. I'm never going to say I'm never going to say that you need to do it this way or the other, or why would you not do that? This kind of stuff, it's all design decisions, right? And we have to make a choice. And often it's tricky when you're both the gameplay, you're both a gameplay implementer and the designer to make that choice. When you're a designer, maybe your trade-offs end up being about what your core goals for the game are, whereas when you're a programmer, you start thinking about the implementation difficulty, you start thinking about performance, you think about how easy it is to introduce bugs, and you might make decisions based on that. So there's a lot more factors going in when you are both the programmer, when you're the implementer, and you're the game designer making these choices. And for that reason, a lot of studios don't want their programmers interacting with designers that closely. They want to they don't want to widen the interface between the I know it's very programmer speak, but they don't want to have a wide interface, high bandwidth interface. They want to have a very low bandwidth interface between programmer and designer for that reason. So the designers can think in isolation and the programmers can think in isolation about these issues. You don't want programmers to make decisions. You don't want programmers making design decisions. So that being said, in this case, I can tell you all the trade-offs programming wise, but at the end of the day, we don't want to compromise what our gameplay design goals are for code, right? As much as possible, of course. Sometimes designers do come up with things that are impractical to do or require a huge rewrite of code to implement. Now, I'm a big believer in restrictions leading to more creative design, like more creative output, right? Some of the best games in the world came out on very restricted systems like NES, SNES, But, we have a lot of freedom these days. We have a lot of memory, a lot of cycles to process this stuff. So I think it behooves us to really think about the design for the design itself, first of all, and then think about how it gets implemented in code. Cool. So saying all that, what ultimately do we want? I think in this case, for the hit events, we want to be flexible and allow multiple hit events, and then we can decide later on whether or not we want to restrict that in some way. But we don't want the code to restrict what's possible in this situation, right? So we're going to support multiple hit events per character. So now what is the implementation decision? Well, we could have a component per entity that stores multiple hit events. So looking here, we could have something like hit. We could have hit, and now I'd have to move hit event from here to here. So I'd have to do, anyway, I would have something like hit events or events. I don't know. What do you want to do? Events equal hit event. And you'd have again, I don't want to, a little slight tangent, but during the gameplay run, I don't want to allocate memory for this stuff. So we'd have a fixed number of events. And it's another decision, like how many events do we want to store, right? We could do I don't know, max hit events. And then we'd have to store it let's say hit events per entity. And I don't know, let's just say 100. We don't want 100, probably. We'd have to max it out. And there's another thing, say it's 20, but there's more than 20 hit events. Then we could either ignore it, the event doesn't occur, we just don't care about it. Or do we want to inform the designer? And at some point, we either do that in form of a message, an alert, an assert. I'm not sure. But yeah, things you need to think about at the end of the day. And we always have to consider, how much memory do we want to store? Use memory. Obviously, there's a limit, right? We don't want to say We can't use a gigabyte for this, right? Okay. Do we want to use even a megabyte for this? Probably not. So, like, what is the max amount of memory do we want to use for something like a hit event? Now, I don't want to be super granular, but just intuition-wise, I'm going to say, even if we store like 20, it's not going to be a big deal. Is 100 going to be a big deal? How big is our event structure going to be? I don't know. Assume it's just like 10 integers, right? So 10 times 4 bytes, we get like 40 bytes. 40 bytes times 10, 400 bytes, 4,000 bytes. Sorry. What that was. What was that sound? I don't know where that came from. Very strange. Anyway, yeah, that is such a discussion going off there. So for now, what was that? I was saying it was like, 40 bytes per structure, and if it was 100, we get 4,000, it's about 4 kilobytes, right? It's less than that, but do you want to use 4 kilobytes for this? No, probably not. Probably not. Okay, then order magnitude less than that, 400 bytes. Still seems like a bunch to me, but we'd have to start thinking, like in terms of like how many entities we'd possibly have. If 400 times 10 entities, which we have for now, is 4,000. So it ends up being a total of something like 4 kilobytes for the whole thing. Is that okay? Probably. So let's just say 10 hit events for now. It's probably not actually going to be 40 bytes stored in the event structure, but just in case, And I think in the future we're gonna keep a running count of how much memory is stored in each of these components. And that's another thing. Do we want to call this whole thing a hit component system? Instead of hit events. Well, this is kind of like our pattern for now, right? It is our default go-to way of storing mutable data in the engine. And I think I mentioned before, though, there's the mutable state that's persistent between frames that's used to calculate the updated state the next frame, and there's stuff that's only needed for the current frame between stages of our pipeline. I think these are one of the things that's needed for the state. We don't need to have this stuff persistent between frames. And if we do need to have parts of it persistent between frames, we can store that in something else. But my experience tells me that we probably won't any state the characters go into can be part of their own component, such as hit stun time, etc., 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 and everything else can be decided from there. Okay, where did we go here? Cool. Well, we're getting close to time here. I know it's been a lot of discussion. I'll give you a few more minutes. So we'd have this hit event component like this, right? Or we could call it a hit component. I want to come up with a name for components that are used for between stages and not persistent between. Oh yeah, we'd have to do something like this, right? And also, the hit component needs to be. We need to know if it's active or not. We have to think about when we iterate over events. Like, if we're just using kind of a raw array like this, we need to store how many events are active. We could do that as a separate variable or inside the hit event itself. Or we could use another data structure like an array list that stores the number of elements inside itself. These are all choices we have to make. For now, I'm going to say event count or event num. Event count is going to be equal, for now, it would be, it needs to be a, let's say, usize. and equal to 0 by default. We don't have a hit event here, so we'd have to move the hit event from the collision system to at least to here, right? We have to move it to here. This part of the hit event component. That should be fine here. And then we'd have to do, we have to import the components inside of our code here. So we'd have to do const component. Let's just say component equals import component dot zig, and then we have to be like, it's not great to have a component dot hit event, but I'm not even hit event there yet, so we're good. Yeah, so we have that. Doesn't even compile. I'm kind of curious. Oh, it's not initialized anything, so it's going to complain. So we would need to initialize this too. It needs to be a what is it? This. Oops. Is that how that works? It does initialize this to whatever data, to be honest. Just defaults at the moment, and no more semicolons again. I need to prevent myself from doing that. Is this how we do this stuff again? Hold on. I'm going to check. It's the other way around. No, this is the right way to do it. Okay. Getting a little better intuition for this stuff. Okay. A little dry in here, I think. Yeah. What is going on here? Expected a thing. Oh, I have S there. What is going on there? It's complaining about this being const. Error. Unable for array size. Really? Why? It works here, right? We give the size here, and is it because this is a const? If I do this, does it work? Start up the compiler is a little slow, my taste. Okay, I guess we have to do that. So, is there another kind of type, a compile time type? Is there comp time variables that I could, do I need to specify comp time or something for that to work? Like constant express in C++. Hold on, let's see, comp time. Okay, so we can do comp time. So comp time by default has to be a const, right? Comp time. So you should know this at compile time, absolutely, right? Error expected. I found a thing. What? Can I not use it like that? Expected a comma, found semicolon. Why would it expect that? Oh, comp time has to be comp time const. Is that how it works? Error expected block or field found const. Okay. So they can have comp time var, but not comp time const. There's no comp time. Maybe. Give me a second here. Trying to learn how Zig works in this case. Error expected blocker field found var. Okay. Let's give it comp time. Comp time. I can see it uses a perimeter. Can I use it as a constant? I don't know. Hold on. Const. Does Zig have comp time constants? It must have it, right? It's really weird that that's not like the default thing you would look for. I would assume const, but const isn't comp time actually. So really is no. Yeah. Really. Okay. Again. Use a perimeter here, use a perimeter, and a comp time function. Again, it's either perimeter or inside of a function. Huh. I really want to know how to use this comp time thing. So again, there's comp time vars here, but never comp time const. A perimeter can be comp time, and it doesn't need to be. But a comp time var cannot exist outside of a function. Huh. Comp time const. Hold on. It's a Zen language. I don't know. I'm just gonna undo all this stuff for now because it seems to be confusing. We'll learn about it. It's in a future time. Okay. Well, honestly, we're hitting at 2 hours now, and I think that's a good 2 hours and 5 minutes now. It's gonna be allow me to like cut the video up into 2 parts. I'm sorry we didn't see any progress as far as what's because on screen here there's a lot of discussion, trying to make decisions. But hopefully next time we can actually get some of these collision events firing, testing to see if they happen when we expect them to, and maybe get some stuff on screen. If you have any remaining questions, go ahead and ask. If not, I'm going to start, tearing down. Get ready for my day job here. But other than that, if I don't see any questions, again, thanks for coming by as always. Appreciate it. Hope to see you soon. If you want to join our Discord community, let me share that here in the chat for those of you who have not seen it. And we also have a GitHub for the project. Let me share that as well. You can download the source code, build for yourself. If you want to keep up with it, make your own branch, do whatever, feel free, go ahead. Do what you like. I think it's MIT license, so oops, I actually linked the wrong thing, sorry. Let me link the right one. Okay. Yeah, I think it was MIT, right? Yeah. All right. But anyway, again, thanks for dropping by. I hope to see you all soon. Yeah, X-Cool, thank you. I hope you enjoyed coming by. Hope I was able to answer any questions you had. And until next time, have a good evening. If you're out in Europe, I guess, have a good early morning. And here in Japan, we got the rest of the day ahead of us. So I'm going to start getting ready for what I have ahead. Anyway, peace out. Hope to see you soon. See y'all. Goodbye.